Hey everyone, thanks for joining us in our today's Twitch broadcast. Let's talk about data show. For our viewers who are joining us for the first time, in this show we talk about databases, we talk about analytics, Gen AI, and all things related to data. Today, again, we have an interesting show that's lined up with our guest. But before that, let me start by introducing myself. I'm Prasad Matkar. I'm a database specialist solutions architect at AWS, and I help the customers in their journey to the cloud. And today I'm joined with Umesh, Ayan, and Subham. So let's start with their introductions as well. Ayan, do you want to go first?
Yes, sure. Hello, everyone. Thank you all for joining with us. My name is Ann Majumdar. I'm an analytics specialist SA supporting at AWS. And today we are going to talk about real-time data streaming with AWS services. And thank you for being here.
Yep. Thank you, Ayan. Umesh?
Hi everyone, thanks Prasad from bringing me on this show. So hi everybody, my name is Umesh. I'm one of the senior streaming solution architect here at AWS, and I enjoy working with all things streaming.
Yeah, that's great. And we'll dive deep into all those services today. Great to have you on our show.
Uh,
And over to you, Subham.
Good morning, good afternoon, everyone. Hello, my name is Shubham, and I'm a streaming specialist solution architect. I focus on helping customers designing and defining streaming data pipelines, and that includes all the services that's required in order to build the pipeline, not only all the streaming services, because often when you build the pipeline, there's more services required than just the streaming services.
Okay, that's great. So, yep, like I mentioned, we have also have an interesting demo, and we'll go into deep dives of the architecture. So, like Ayan mentioned, we are going to focus on designing the real-time data architectures for the AI agents. But before that, let's start with what what is the real-time data architecture? What does it actually mean? Let's start with that first.
Sure. So I would go with that, and then thanks,
Okay.
Prasad. Okay. So for the folks who are not aware of like what is
Hmm.
real-time data means or real-time streaming means, so streaming, as the name suggests, is a stream, right? So it's a continuous flow. So when we talk about streaming in the context of data, so like data streaming, right? So there are people often get confused between the video streaming and the data streaming, isn't it, right? But then we are talking today here specifically about data streaming, right? So what
Hmm.
is data streaming? It's a continuous flow of data. So that is what we call as a data stream, right? And there are multiple different ways to build this architecture. Like how do we create this data stream architecture, right? And that's essentially is nothing but like is a real-time data streaming architecture. And at AWS we have recommended or prescriptive guidance as well. We have lots of white papers and other things where we talk about that, how do we build that. But if I have to explain it in those simple or layman terms, right? So typically there are two types of architecture when it comes to data processing. It could be a batch processing, or
Yep.
it could be a T-stream processing. So what's the difference between the batch processing and stream processing? So the batch processing usually happens on in the batches. So in the batches of the data, it could and a particular interval of data
Yep.
time. Sorry. So what I mean by that, so it could happen every minute, every day, or every week as well. So based on like how we want to process your data in batch.
So it's
But
basically like grouping the data together and then processing
yes,
them in a batch.
exactly. So
Yep.
you are chunking the data. You are chunking
Yep.
data and then processing it together.
Yep.
Whereas when we talk about the data streaming
Mhm.
architecture, right? So you are continuously getting data, but at the same time, as soon as it arrives, you are processing that data. And such architecture, we call it as a real-time data streaming architecture. So what's the difference usually? So when we talk about real-time data streaming architecture, we talk about between milliseconds to seconds. That's something we call it as a near real time, and near real time can be different
Mhm.
based on your use case. It could be
Yep.
subjective. For somebody it could be seconds, or somebody it could be milliseconds as well. Yeah.
Yep. Yep. Thanks, Umesh. And we discussed about the real time data streaming architecture. Now, what are the use cases that you've generally seen in your customer conversations? Like, where is the real time data streaming architectures being used?
Oh yes, definitely. And I would ask this question to our audience as well, right?
Uh
So
huh.
maybe You can open the chat as well. And then where have you seen the uses of real time data? Can you give me an example? Maybe every day, like we use it for taxi hailing application, right? So which is one of the most popular taxi hailing application that we use. What does it come to your mind, Prasad?
Uh, so sorry, I missed that. Sorry, can you?
So what is the most popular taxi hailing application that you use normally?
So is it the Uber thing?
Exactly, yes.
Yep.
So
Okay.
Uber is coming up with exciting new features nowadays. If you have used that or
Mm-hmm.
seen that, for example, if you are taking a taxi, if you are booking a taxi, and then continuously it shows you the route in your
Oh.
app as well. And
Mm-hmm.
as soon as if there is a diversion from your predefined route, it
Yep.
automatically sends a message to you, or like and then they ask you like, are you okay? How does it do it? So because it is continuously interacting or sending data back to the servers backend systems, isn't it? And that is that can be an excellent example, right? So where real-time use data can be consumed and then it can be processed in real time and
Yep.
can be used, right? What could be the another example? Maybe many of us do a stock trading apps, use stock trading app. So the ticker prices continuously keep on moving, right? So that could be another example of that. But if I have to categorize these use case in a bucket, so it could be I could put it into like a, let's say, top three use cases could be such as real-time analytics,
Yep.
like if I want to monitor the transaction of a banks, if there is a fraudulent transaction is happening, I want to prevent it then and there. So the prevention is better than a cure, isn't it? So I want to stop the fraudster in their tracks. So that's very popular use case in real time analytics. Another could be like event driven services or event driven application. Like if as soon as there is a particular event is happening, let's say in a factory, sensor is being monitored and there is a anomaly is detected,
Mm-hmm.
as soon as that anomaly is detected, we want to take some action on top of that. So that could be another example of the event driven application. And the third thing could be a third category of the use case could be personalization and recommendation. All of
Yep.
us use amazon.com, right? So and the black friday is coming up, so we get this recommendation in our when we browse amazon.com. So our clickstream activities that's being captured in real time, and also it suggests like, okay, you might like this product, or this product is relevant, or if you buy it together
Mm-hmm.
you get certain kind of discount. So that could be like personalization and recommendation. That could be a third use case. So these are the top three use cases that I could see. Event driven application, real time analytics, as well as personalization and recommendation, I would say, uh, for very popular use case for the real time data streaming data.
Yep. Sure. So now let's look at the chat. We have uh, we have Ibrahim, who's the chat cheerleader for today. He's posted the link as well for the real-time data architecture, the streaming architecture that Umesh was talking about.
Exactly.
Uh, then we have Jeff, who's the producer as well.
And
Uh,
Jeff, if you could bring up the diagram.
yep. Okay.
So this is how that real time data processing pipeline looks like.
Mhm.
You typically get source, like which is continuously emitting these events or data, let's say, and you are capturing that data. You want to ingest that data into some kind of system. For capturing this stream of data, you need a special type of storage, and we call it as a stream storage. A typical example could be Amazon managed streaming for Apache Kafka, which is nothing but manage open source service based on Apache Kafka, or Amazon Kinesis data stream. So those are specialized type of storage services which capture this data stream and then store inside that. And then once we have that data stream, we want to take some action on that, maybe real-time analytics or maybe personalization and recommendation, or like I said, event-driven application. That component fits into like stream processing component. Okay, that processing sits into that this stream processing component. And after
Mhm.
we have done that or calculated that action, we'll send it to a destination. So this is how typical real-time
Real-time.
streaming
Yep.
architecture or pipeline looks like.
Okay. Yep. Thanks. So yeah, we have Mike joined as well. Awesome guys. Leading
uh, he
edits. I
mentioned
think
like, don't remind my wallet.
he's watching from LA. Thanks for joining. Then we discussed. I think this is for your question that you had about what are the examples of real-time streaming. So Learn Addict has mentioned e-commerce personalization, then fraud detection, IoT use cases as well. Um, and yeah, uh, so yeah. Now let's continue with the topic for today. What is an AI agent, and why is it important, and how does agentic AI align with the streaming architectures that we've discussed about right now?
Yeah, so let's first take a definition of an AI agent and particularly how I see this. So I think of AI agent in three dimension. One, as a sense of agency. What does it mean is that AI agent has an ability to perceive the environment it's working on. And what I mean by that is ability to understand the data it has got access to, and it need to work on the data. The second is it needs to what it is doing once it has got the perseverance of the environment, it is able to reason about it, the prompt that a customer has provided, that what the agent is providing, and it can act on it autonomously, and that then is able to reflect back that what is the outcome of it, and if any of those actions need to change. So that reflection process is very important. With agency, is also another part is the autonomous thing. That means the AI agent, they act autonomously on the um,
Mhm.
different data points and systems, and they can act some they can drive some decision making. And for doing that, they can collaborate with other agents, they can interface with other applications, and they can work on the data, they can use different protocols to talk to other different external systems. And the third is very important one, if and only if an agent is granted permission, that's why the authority comes in the picture. The agent should have a red line boundary through which within which it should act. It should not go beyond that. It should not carry out any activities it is not meant to do. And security is job zero, not only in Amazon but
Yep.
also in your organization as well. So think about that. When I think about AI agent, is like autonomous activity, which is the ability to do reasoning and acting on the data, but also think from dimension of agency, autonomous activity, and authority.
I think there is a specific word for that, Shubham, isn't it? I think we call it as a guardrails. Is that the correct word?
That you can say that, of course, it's the guardrail, right? When you are providing some guardrails to work on the agents, you're also kind of giving the authority to act on certain boundaries, remaining within that boundaries. So that's correct. Yes. And now, if I think about how streaming data architectures and AI agents come together, it's like think about streaming architectures. So you're getting a stream of data which is continuously flowing through, and you have built some systems that has helped you to take some decision making. Let's take real-time analytics. What it is doing, real-time analytics is nothing but you're able to process the data in motion and able to calculate some kind of analytical data point. For example, you're counting how many matches a gamer has been playing for the last session, and how many matches they have won and how many matches they have lost. Okay.
Okay.
Now, the real-time analytics, think of a business point of view, like what's the business value that real-time analytics is providing unless you're able to act in real time. So
Mhm.
that means streaming data is bringing your data live, but if you can make your system intelligent enough, it can actually act on real time. And that's where AI agent play a massive role in terms of autonomously taking some actions based on the findings of your stream processing systems.
Okay.
So I'll give you a concrete example. So let's take a gaming experience. So a customer is playing some game and they're not happy actually with the whole experience because maybe it's very difficult for them to kind of go to the next level. They're losing the game, or maybe the coins they have, the rewards they're getting in the game is not very rewarding enough. So there's a good likely event that they would actually probably leave the game. If we
Mhm.
can tap into that customer experience and provide kind of any kind of support to the customer in terms of rewards during that time when he or she is playing the game, that's when we are able to retain the customer and make a revenue impact.
Mhm.
That's what an autonomous system can bring into the play, and AI agents have a role to play over there. I'm not saying only AI agents can do that, but yes, AI agents has a role to play in terms of deciding what kind of uh, activities should be carried out. Somebody is probably rewarded with, let's say, an extra life in the game. Somebody is provided with a reduced difficulty level. Somebody is provided with some coins, actually. Somebody's trial period has been extended, let's say.
Yeah.
And it depends on every user's experience, every user's, the personalization that you can drive through this whole process.
Okay. Yeah, that's an interesting use case. So with the real time data, you always had the data being available in real time. Now with the agentic AI, now you can take fast decision making, like the examples you mentioned in the game. Yeah,
And I
makes
think I would like to add one point over here. So people often get confused between the AI and the agentic AI, right? So the agents, so it's just a kind of an evolution. So we might have heard AI and then generative AI, and nowadays we are talking about agentic AI. Everybody.
Mhm.
So what we are talking about, like how do we combine agentic AI with the real time data? So it's really crucial. Like when you combine both of these things together, it's exponentially gives us like return on investment. So it's like altogether opens up new business proposition for the business.
Yep. So, Shubham, you mentioned about agentic AI and how it fits into the real-time streaming architecture. Now, if you have to embed the agentic AI on an existing streaming pipeline, does it need a lot of changes? Would the customers need to rewrite a lot of code if they want to embed it into their existing pipelines?
Actually, this is a great question, and in today's world, when you are having this conversation with customer, we are getting this question very often, like what it means to
Mhm.
bring an agentic AI functionality in my existing system. Do I need to actually refactor the whole project or so? What you have found is that it's not that don't what is like customers already have the data foundations. They have built the
Yep.
data pipelines to kind of um, generate some events on which they need to take some actions. So for example, think about the gaming experience. Let's take this gaming experience, right? So you've already kind of built an application and pipeline
Mhm.
that helps you to actually identify which customer is more prone to churn. Churn means the risk of losing a customer. You
Yep.
already figured out which customers are probably, we are able to lose that, and we can lose a customer if we don't take any actions. And we have used different traditional technologies to kind of figure that out. Now, once you have figured that out, you can actually use agentic AI to actually make events call to kind of take a decision making. So, in fact, you can think about agentic AI comes at the tail end of the decision making, where it
Mhm.
takes whatever already been delivered by your stream processing pipelines,
Yep.
taking that and actually doing the last leg of decision making in terms of providing the experience to the customer. So in my view, you do not need to change a whole lot of for most architectures, you do not need to change a whole lot of the pipeline in order to make it more agentic. You already have it, so just need to figure out that where it needs to make sense to, in order to take the events and react on it.
Yep. Okay, that makes sense. So let's look at the chat. Um yeah. One question that was brought up is, uh, please ignore if the question is not relevant. How does agentic AI can handle illusion? One of the challenge the customers face while thinking to adopt it.
I think
So,
it's a great question. Yeah. So there's no one answer to this, and it boils down to a lot of things. So first of all, it depends on the data also. Like
Mhm.
first, and that whether you have the data, right data, based on which your agents are able to take a decision making. The second is the big thing I mentioned about authority. That's where your guardrails, your red line comes into the picture. So to make sure it cannot take any kind of activity that is not meant to do. You should have proper input validation and output validation, and so make sure that whatever action is taking, it's kind of, it is permitted to do. And the third thing is use a feedback loop. Think about, maybe your agents are not able to make good decision making at the right place.
Mhm.
So imagine, I'll give an example. The next thing, so imagine that in your game experience, you have found that a customer who is having a bad experience, it's probably good if we can actually provide some bonus point to the customer in terms of some kind of, some bonus point to the customer. But that didn't may not work out. Maybe
Yeah.
even after giving that bonus point, the customer is still not happy with it. And how can you
Mhm.
figure it out? Maybe the session duration of every game sessions are not actually increasing. You are seeing that continuously that the session duration is actually going down, and the number of gameplays by the customer is also going down. So that means the reward that was given to the customer didn't drive the exact value. So that means that my agent didn't perform well in terms of calculating the kind of what it needs to do. And that is where the feedback loop will help you to kind of make it better. So now you can say that with bonus point, with this particular situation, when the customer is losing games, just
Mhm.
by giving bonus point, I didn't see any retention of the customer, because the other signals of the customers are still going down. So it comes down to how you actually kind of build a feedback loop process. And
Okay.
finally, you need to provide your guardrails to make sure that you have a playbook actually around what it is need to do, and your agents are abiding by those guardrails on that.
Okay. Yeah. Hope that answers your question. But yeah, there's one more question around this. Is there a possibility of iterative trainings for the agents to reduce hallucinations, being the one that you mentioned about feedback loops?
Yeah, I think let's do one thing actually.
Uh-huh.
Let's do some of the design patterns, and one of the
Yep.
design pattern is meant to explain this part. Um,
Yeah. Let's focus on the common design patterns. So.
yeah, so I would request you to bring up the screen of the design patterns, and so yeah, I would go to him. You know, so the first one I was talking about was a reactive agent on an alert stream, the one that I talked about, that you already are getting some raw events actually, and you are processing those raw events. And in this scenario, if you look at this particular slide, it's the use case is about fraudulent login activity. How can I detect a fraudulent login activity, and what triggering response I can do? So you are getting this raw events, all the login data, and you're using, let's say, Flink as a rule engine. Flink, those who are not aware of Flink, Flink is a stateful stream processing system, and we provide a managed Flink way to actually write Flink code and run it on AWS. So you can get your raw events, process the data, and you can say that this is my alert actually. So you figured it out from the raw events, which one are actual alerts. And now you can actually invoke an AI agent, which is in a different service or so, let's say in the Bedrock agent, or and you are basically using Lambda function to invoke a Bedrock agent to decide, is this a false alert or is this a correct alert? And the agent will decide on that based on this. And you have some guardrails in place already, which is not shown in this particular architecture. And based on this, you do some decision making, like whether you call an external API, whether you notify someone, or whether you block the access. So the pattern here is not to invoke the LLM models on every event on the raw data, but only on the alert event. And there's a good reason for that. First of all, imagine if you are building your streaming pipeline and you are actually,
Mhm.
calling your LLM model on every event. If you are sending 10,000 events per second, and if you are invoking LLM call for every 10,000 events, your whole pipeline will be super slow, because still now the LLM models take some time to reply back. It can take few milliseconds at the very least, but that few milliseconds or so can have a huge impact when you have a high volume of events coming to the pipeline. So that is why the recommendation here is use your stream processing systems to trace those alerts, because those are proven mechanism. Those are the rules you've already built in, and use your agents to call on the alert stream of event, not on the raw events.
Okay. So you'll
Uh,
use your existing pipelines to process the events as they come in, and then
correct.
based on the alerting is where you'll have your agentic AI architecture at the end of the layer.
Right. Yes. And the second pattern is about building a multi-agent workflow. is often when you're building an agentic workflow,
Mhm.
it's not just one single agent that doing the job, because your agents, you're thinking about agents to define with a goal in mind, right? Agent should have an intent, what the agent is tasked to do, and the agent is basically focused on delivering that particular work, unit of work. Now, that means you are getting a login data. Imagine you are feeding it through some kind of Kafka or Kinesis or so, and you are calling the first agent, which is doing some processing and sending it to another Kafka, Kinesis, SQS, this kind of streaming storage or messaging systems. In that way, you can build a pipeline which is asynchronous in nature and which is linear in nature. You can build that. Similarly, you can also build a pipeline where you have parallel activities. So imagine one data is taken up, and then you are making multiple agent calls on the same data, and each of those agent does a separate part of the data, and then it actually takes some actions. So it can be parallel or it can be linear, building in multi-agent workflow that you can define.
Okay.
The third one, and I would say this one, let's talk about this one, the most important one. Let's say um, this is a human in the loop pipeline where you are determining search pricing for rideshare app. Okay, let's take any rideshare app, and those rideshare apps, the way it works is that they have you are basically getting the city, the zone where the rideshare app is working at this point, and the demand of that particular location at a particular point in time. For example, I'm based in London. If you look at the London city demand of the rideshare apps in the morning time, it will be different than what it is in the midday, than what it is in the afternoons, right? And you are ingesting the demand and availability data. Now you are basically invoking agents to kind of analyze those demand data with your existing guardrails, and you can see a memory over there. And there are two types of memory. One is a semantic memory, one is the, let's say, text-based some memory you are using. And those are the ones that provide you some guardrails, some conversational text, that what exactly you have done actually in the past, what information was provided in the past, those kind of details. And you are making an agent call which takes a decision whether you should increase a search price or not.
Mhm.
If it stops, okay. Okay, yeah. So if it increases the search price or not, and then once the decision is taken, you kind of dump the decision into the DynamoDB and expose it via internal pricing portal. And there is a human analyst sitting at the end of that portal who is looking into it, search pricing details, and say that should I approve it or not. There's a good reason he or she should not approve most of them, and there's a good reason they might be approving it. If it's approved, that search pricing is basically available to all the apps and to the app and to all the customers. But then what happens is that once the search pricing is approved, you are also kind of tracking what is the outcome of applying the search pricing. What are the right acceptance? What are the complaints, the cancellation, based on the search multiplier? So imagine if you're paying 30 pounds for a particular ride, now if you're paying 40 pounds for that ride, you're
Mhm.
basically trying to figure out, with that increase in price, did my ride acceptance go up, or my complaints go up, or my cancellations go down, something like that. And that will help you to kind of iteratively tune how your agents perform, because that data has been processed by your application and again written back to the DynamoDB memory. So the next time when the agent perform, it has got the recent feedback.
Yeah.
So for example, if you look at the right hand side of the screen, the recent feedbacks are like, with a 1.5x multiplier, I found that my complaint rate was 37% higher and my right completion is 52% less. But with 1.3x multiplier, my complaint rate is reduced by 18% and 74% completion rate. Now that kind of gives you a sweet spot that maybe we find a good multiplier in between 1.3 and 1.5x. And that's where you can figure out that I should probably go for 1.35 or 1.4x multiplier next time. And that will increase the revenue probably and still probably give a better value. And iteratively, it is tuning. So coming back to your question, yes, you are able to iteratively tune your application, and that's because you're only measuring the outcome of the decision by the agent and
Mhm.
keeping it as a feedback to the agent for the next agent call.
Yep. Yep. That's great. Thanks, Shubham. Uh, so yeah, now that we've talked about what are the design patterns with an AI agent, what are the AWS services that are best suited for developing with the streaming architecture?
Yeah,
And
I
you
think
would,
Ayan, do you want to take that question? I think we have excellent demo coming up, and then maybe Ayan would
yep.
be able to explain
Yeah.
that while he's showing an architecture, all the different messaging and streaming services
Mhm.
that AWS offers. Ayan, over to you.
Yes, so before doing the demo and to answer the questions, Prashad, I'll explain all those services during the our architecture review sessions.
Mhm.
But before presenting the problem statement and how AWS will help you to implement that solution and the high level architecture, I just want to discuss the use case. So for this today's demo, we are going to present the Geofence alert processing using the AI agent. So what is Geofence? So Geofence in a connected vehicles, think about it's a location-based technology that creates a virtual geographic boundaries which help you to enable think about like automated monitoring, vehicles tracking, and triggering a specific action when a vehicles enter, exit, or operates within the predefined zone. So that's an use case we are going to build, and definitely the AI agent will help us to monitor those alerts because it's not possible like a human. If you have a think about you have a fleet of vehicles, like there's thousands of fleets of vehicles, we do not have to go through each of the alerts. So
Mhm.
agent will help us which is the valid as a alert, and based on that you can take an action. So we are going to build that solution for today's demo. And now let me share my screen also quickly. Let's see, share screen.
And for the audience, like just to connect dots back to what I said earlier at the start of the show, like okay, how these different ride hailing apps works. Okay, if you go offsite or offline, off the track, then immediately detect is get detected and you get a message, are you safe, is the ride okay, do you want us to terminate it, or do you want to, so you are supposed to reply back. So you could tie it back that use case over here as well.
Sure, I'll do that during the architecture sections. When I discuss the high level architecture, I'll go through that. So this is the use case we have discussed. Now, if you would like to implement that use case, what is the problems you are going to face? So organizers face challenges in terms of, let's say, the monitoring the vehicles in the real time and the taking the action when the geofence events occurs, and that leads the security risk, right? And when I said the security risk, think about let's say the unauthorized access to the restricted areas, or asset thefts, or the misuse. Similar go to the operational inefficiencies, like inability to optimize the route management system, let's say just like Umesh mentioned, Uber is defining, like let's say the any taxi riding app like Uber or Lyft, how you can manage the route, right? So that's an operational efficiency. Then the lack of real-time visibility, let's say you have a like enterprise is a one of the big car rental company, like how you they can manage the fleet in a real time, how they can manage the fleet, get the data from the vehicles, ingest the data in the real time ingestion, and take the business insight. So how they are going to implement that kind of solution. And also sometimes we have observed the compliance issues, and all this cause the business impact. And when said to the business impact, it might be like increase the operational cost, reduce the customer satisfaction, and the potential revenue loss. So that's a problem we are going to solve today. And this is our solution. So the high level think about that, first we need to create and manage the virtual geographic boundaries for each vehicles or the fleet. When I said the fleet, in the fleet you can have thousands of vehicles, but you can have multiple fleets also, right? And then you have to provide the real-time location tracking for all those vehicles. So in that way you can know when the vehicles enter or exit that particular geofence, which is already predefined rules for that particular vehicles. And the next thing is that generate automated alert for that boundary violation. means like it will send you alert and when that vehicle's geofence event occurs. Now once you have that alerts, agent will help you to determine like which is the valid alert, and that way you can take an action and create an end-to-end solution. uh, this is our architecture. Before going that, Umesh or Shubham, do you want to add anything?
No, I think you've covered most of it. Just want to say that this one we're using a Strand agent. So if you haven't looked into the Strand agent SDK, feel free to check it out. It's quite an easy way and cool way to actually build your agents, and you can deploy it in Bedrock.
Yes, thanks, Shubham.
Yeah. So from my side, so I just want to ask one question, Ayan. So you mentioned something about creating geographic boundaries. So are they called as a geofence? Uh,
Yes.
okay. Yeah.
So what you can do, like it's an basically the logical boundaries you are defining for
Mhm.
each vehicles in the fleets. So if it is, let's say, in the Seattle region, you have a vehicle, and you can define a rule. If it is going outside the Seattle, you will get an alert. So
Right.
that's problem statement.
Okay.
And that becomes my geofence then. Okay. Seattle area becomes my geofence.
Yes.
Okay. Okay. Perfect.
In the architecture, maybe you can see few of the services is new to me, new to you, and I'll try to explain as much as possible. But we have some documentations also around that for each services. We can share those links with you. Feel free to check those things. So as you can see, as we are doing the geofence using for geofence alert processing using AI agent, that use case we have a vehicles on the left hand side. So vehicles will send the telemetry data, like sensor data, to the IoT code. So IoT code will provide you the secure connections between your connected vehicles, and it has the message routing capabilities. Once you have a message in the AWS IoT code, it will stream those data into the MSK. So MSK is a streaming service which is basically help you to securely stream the data, fully managed, highly available Apache Kafka services. Similar architecture you can also build with the Amazon Kinesis. That is also AWS services. It's also a managed service and provide the low latency streaming application. So here, once the data is landed in the MSK capture all those streaming data. And now you have an Amazon managed service for Apache Flink. So Flink is nothing but it's for use for the data validation or the data enrichment. So Flink consume those data for the MSK and validate if the geolocation of that particular vehicle within a defined geofence. So if it is not within the geofence, it will send an alert. Now you have an alert, but maybe each vehicles can raise an alert like 50 alerts in a
Mhm.
day. It is hard to go through all those 50 alerts, so that's why the stand agent come to the picture. So we have one of the alert analyzer agent, which is utilize the LLM models, which generate only like valid alerts. So what it does is take your payload or the JSON payload, and then it will create a structured way a JSON format. We'll show this in the demo and write back to the SQS. I just want to add another thing. As you can see in the diagram, there is a DynamoDB also with the Flink. What does that do here? So DynamoDB, you can mention the geofence rules. So let's say you have a vehicles, and that's the Seattle region's vehicles. You can define that vehicles rules here. Let's say if it is outside of the Seattle's latitude and longitude, it will give a like geofence event kind of things. So that's using for the dynamic for the lookup purpose, and Fink will all those two validation. Now coming back to the, and then it will write to the our geofence alert topics in the MSK. Now coming back to the strand agent, the first agent is basically taking the like all the valid alerts and check all the alerts and check whether those are the valid alert or not. And based on that, it will create a structured JSON format and then write back to the SQS. Why we are included SQS? It's basically the decoupling the architecture. In that way you can agent can talk, so the alert analyzer agent and the alert publisher agent can talk asynchronously. In that way we can build a robust backlog processing and the fault tolerance. Now, the email agent or the alert publisher agent is basically taking this incoming JSON structured data, and it is standardized in a human readable format. And then it will give you the information like vehicle status, then the impact of the alert, root cause of the alert, and the action recommendation. And the last but not the least, we have a service called Amazon SNS, which is a simple notification service, which is help you to send the notification to the user via email and the mobile phone. So this is the high level architecture we are going to build today.
Yep. So one question that I had is around the alert analyzer agent. So it does compare the data to classify like which are genuine alerts of the streams that have come
So it's utilize LLM, and it call one of the services we have
through.
Amazon Bedrock. So Bedrock will provide you all the leading AI companies LLMs as well as the Amazon's LLMs. So you can call any of the model available within the Amazon Bedrock,
Mhm.
and that LLM will help you out of, let's say, the 50 alerts, which is the valid alert.
Okay. And here the DynamoDB is primarily used to store the latitude, longitude of the
Yes, it's called the,
location.
you can
And
define those business rules, like let's say
okay.
as I mentioned in the example, let's say one vehicle should not go beyond the Seattle region. So you can define that particular vehicle's latitude, longitude, and if it is go beyond that, that's a geofence event, like it should not go beyond that.
Yeah.
So
Okay.
now I'll share my another screen quickly. So now the most interesting part, we'll see these things in action. So let me, I'm just log into the
Yeah,
accounts time because it's idle for more than 10 minutes or so.
yeah.
Bear with
So
me.
while Ayan is sharing his screen, so how many of you were able to manage or map those different services with the architecture that we earlier talked about, right? Real-time data streaming architecture. Like, were you able to identify what was the source, what was the storage, and then what was the processing in that architecture? What Ayan showed earlier. Well, and let me know once you're ready. So,
Yes,
Yeah.
I'm ready. Sorry
so
about that.
perfect.
So for the demo, we don't have any actual vehicles here. So we are creating a EC2 instance. Think about as a vehicles, and it will send all the telemetry data. Uh, so I'll quickly showcase you. So this is our EC2 instance. It is now in a running state. Let me connect that. And let me pull the information. And if I see the status, see, if you see the EC2 instance is continuously generating the vehicles telemetry data, and these are the, we have a 10 fleets available. So vehicles, you can see the fleet hyphen then the numbers, and this is all the street name for the Seattle region. It can be any region based on your location. You can modify those things. So here we are using the EC2 instance. So EC2 instance is the for the generation of data. Once you have the data, it will send those like a simulator. So EC2 simulates all those data and then publish those data to the AWS IoT core using MQTT protocol. And I'll quickly showcase you the IoT core also. And in the IoT core, we have defined one rules. So I'll open that rules also. And this rule is already created, but I will edit that to show you the configuration. So all the vehicles EC2 data is write to the IoT underscore data MQTT protocol, And so we are taking those data. You can see the select star from IoT underscore data. So in the IoT rule, you can filter those data. So let's say you have a 10 columns is coming from the sensor, and you can filter those data. But here we are just sending all the data to our target. And if you remember the architecture, we are sending those data to one of the Kafka cluster, which is the Amazon MSK cluster. And we are giving all this information for the MSK. And I just want to call out here, we are using the SASL Scrum authorization to communicate between IoT core and the MSK cluster. And now if I see the MSK cluster, so this is our MSK cluster, which is up and running, which is our which is process all the streaming data. Now we can see all the generated data which is coming from EC2 to the MSK cluster. So
Mhm.
now go back to the EC2 instance one more time, and we'll set up the broker configuration first. Broker is nothing but a like a cluster configuration. Think about the MSK cluster configuration, and here we have a two topics. So two topics in the MSK cluster. One is the, you can see the Geofence alert, which is our destination, and which is our for here we have a vehicle telemetry, which is basically consuming all the data from the EC2. Now, if you want to see the raw data, I'll showcase you the raw data which is coming to the MSK cluster. It is continuously floating. So you can see all the vehicles ID, geofence ID. So this is the data we have receiving from the MSK. And I just use the MSK vehicles telemetry topics to see this data. Now, once your data is landed in the MSK, we have a Flink to process those data. So think about the Flink on the validation and the data enrichment. And before going to the Flink, I just want to showcase the configuration also. So it is already in the running state. And if you see the configurations, here we are passing the DynamoDB tables. DynamoDB tables where we are defining the rules, like all the geofence rules. And here we have a Kafka cluster, which is our source for the Flink. And if you see here, we are mentioned the vehicles telemetry, which is the Kafka source. And then we are writing back to the, again, the Kafka cluster, but this time a different topics, which is called Geofence alert topics. Now I'll showcase you the quickly the DynamoDB table. It's a NoSQL database in AWS services. And if you click on the tables, and this is the Geofence, and explore the tables, you can see one of the rules we have defined, and we can give this information like latitude and longitude and particular for all the, like you can define multiple rules here in this geofence uh, tables, but for this demo we are only create one single rules.
So one thing to highlight over here is that when you're defining the geofence, think about geofence is a polygon, and that polygon is created based on some latitude and longitude. And it can be with four data points, it can be with five or six, depending on how many data points you need to create the particular polygon, and that is defined in this rule.
Yep.
Yes. Yeah, as Shubham mentioned, we use the geometry package here behind the scene, and in the Flink code is nothing but it's a Java-based code, and we use the one of the jar file. Uh, it is already deployed. I cannot showcase you those things, but um, we can share some GitHub repository with you
Yep.
guys where you have those codes available. It's ready to use for you
Yeah, I
guys.
think there were a few questions in the chat related to it as well. If you can share the GitHub link for this, and similar to the IoT code as well, the one that you did show.
Yeah.
Uh, Now, in the interest of time, there's one more question as well, which I would like to quickly bring up. Like, how is the latency being taken care in real-time decision making?
So when you said the latency, here in the MSK cluster, it's a all the data is coming from the IoT code.
Hmm.
That is, it's a real-time ingestion. So whenever the data is available in the IoT core rules, it will automatically ingest it in the MSK cluster. And then the fling also, it's a real time supported. It's not, we are not using any near real time or any kind of services here, although AWS provide the near real time services also like Amazon Firehose, but everything is in real time. There is hardly any latency you can observe here too if you use this solution. uh,
And just to add over there, latency is a very kind of term that needs to be looked from an end-to-end perspective. Um, if you look at the overall pipeline, when you benchmarked and looked at it, we found that from the data ingestion to actually Flink processing the data and writing it to the alerts topic, we found that it was coming around in double digit milliseconds, over a period of time, like the whole pipeline. And however, because we have a strand agents that's working on top of those alerts data, Geofence alerts, that is definitely going to add a little bit more latency compared to the other pipelines. So individually, we found that the overall we found that the latency is coming within few seconds actually, which is very good compared to what the purpose, how it is actually driving it. As I mentioned, real-time analytics plus real-time actions.
Yep.
Thank you. I just quickly showcase you the agent part. So agent part, you have a prompt. If you see, we are giving the prompt, you are mentoring the IoT vehicles monitoring analysis. And here we are defining the prompt, like if whether that alert is valid or not. So if it is a pre-approved movement, authorized entity, schedule maintenance, then do not raise any alert because those are the valid scenarios. And here also, as Shubham also mentioned, right, we are talking about the feedback loop. So here we are publishing the data in the one of the DynamoDB tables, which is called vehicles alert audits, which is for the audit trail and the feedback in the loop. And then we are sending those data to the SQS, and this is for the alert agent. And now I quickly go back to the SNS publisher. Here we have, if you see the SQs as a source, and the destination is the SNS. Again, here we are taking all those things in the prompt. So you're telling like, okay, you have this JSON format. Now, out of those JSON format, make those JSON is a human readable format and make this 4 section: current vehicle status, root cause of this alert, impact of the alert, and the action recommended. And
Uh, and one point to add over there, Ayan. So if you take a look at the prompt, so prompt, can you expand on the prompt? So prompt is like very descriptive in this case, right? So we have reiterated over the prompt, right? So it's not just like a one line or two liner prompt, like we enter into like some chat GPT or text-based agent. So the better the prompt you will be, the better your outcome will be. So we have gone through the iterations to improve the outcome of this agent as well. So
Mhm.
that's really important. So you have to there are like there is art, right? Okay, so prompt engineering, how descriptive or how should you create your prompt? So that's really important in this case.
that's a
Yeah.
good point you mentioned. Yeah. Yes, and the final output looks like this. So I'm getting continuous email. I just want to share one of the email, like how it is looks like. And let's see if I can share that. It is in my email box. And I have to go back to the switch screen, I believe. I have to do the stop sharing and share screen, window. Are you able to see the email, like which is we just now received alert analyzer 90? Yes. This is the format where like you will receive. So if you remember in the SNS publisher alerts, we mentioned the correct vehicle status, why the alert is raised, impact of the alert, action recommended, and in from there you can take the action. And this is the end-to-end flow, how the agent will help you to get whether that alert is valid or not, and based on that you can take an action. So that's all about the demo for today's session. Thank you.
Yep. Thanks, Ayan. That was really good. It helped us understand um, a lot of things in the pipeline, how real-time streaming data in combination with how the AI agents can help you, take different actions. And what was also very useful is the various design patterns that Shubham did cover about as well. Let's look at, yeah, Ibrahim has shared the link. Uh,
Yeah, I think
and
regarding the GitHub link of this particular
Yeah.
project. So we are coming up with a workshop actually. I think the
Uh-huh.
GitHub is not there in the public GitHub yet. We have an
Yes.
internal GitHub in AWS, so it's there. So we need to publish it and need to share. But this is coming up as a workshop, and please keep a look into the workshop studio when it comes out. And I don't know how to reach out to you guys, but if there is a way you could reach out. But Prasad, is there a way to reach out to
Yeah, so
the
we will
audience?
publish, we do publish the show notes for each of the shows, and we'll
Right.
include all the details there as well, so the audience can have a look at
I see. Okay.
it. Yep. And one final quick question on this one was, can we trigger the alert to WhatsApp, Slack instead of an email?
Oh, absolutely. And this is
Yes.
the whole purpose of it. If you can integrate with the Slack or WhatsApp API, you can do that.
Okay.
So
Yeah.
it's a event, right? So event you can integrate with any of the systems. So it's just up to you. Yeah. So it's just an API call. So it's possible. Yeah. And I think, yeah, it's one of the important question was like, okay, are you guys doing any kind of POCs? Maybe just type into chat using any of the agentic AI or using AWS Strand agents.
Hmm.
We would be really happy to listen what kind of use cases you are currently working on, like with real time data or streaming architecture, something like that. So if there is any comments you want to leave in the chat, please do it.
Yep. Absolutely. Yep. That's very useful. Yep. Thanks, Ayan, Shubham, and Umesh. This was a really good demo, and really great insights about this topic, and hope the audience did enjoy and learn from this as well. To the audience, a big thank you for tuning in to our show today, and do look forward to the next episode at the same time next week. Uh, and again, thank you all, and have a good rest of the day. Thank you.
Thanks all.
Thank you.
Thanks all.
Thank you. Cheers.